Hello class, welcome to this video on Unit 1 multiple choice practice quiz. So let's take a look at the results. Let's see how you did. Number 1, the graph that's below displays the amount of time to the nearest hour spent on homework per week for a sample of students. Which measure of center and variability would be most appropriate to describe the given distribution? And I would suggest pausing and see if you can answer the question and see if you get it right, just to give yourself feedback. All right, so first one, if we look at the graph of this distribution, it appears to be skewed right. And therefore, remember that if it's skewed right, then the mean tends to be more to the right. So we'll say that that's your X bar. And then the median tends to be right close to where the mode is, right? The mode is 15 here, but the median tends to be the 50% mark. So if I wanted you to identify the 50% mark, well, you would have to add up these numbers, right? 8, 12, and so on and so forth. That's 20, 34. Then you got 49. Then you got 54 or 64. So if you add these up, you would get about 97 or so. If you add up those bars, and then you would have to figure the halfway of that. So half of 97 is 43 and a half. So then you would get to when you would get to around 43, that's your halfway point. 20, 34, 49. So that's around the halfway point, which, you don't have to add it, but to figure it out, I'm just showing you in case they ask you for specifically what the median is, or specifically what the, where things are. So then this is the median around there. And then, so then the average has to be somewhere to the right of that, because it's skewed to the right. So and if that's the case, then that means you're going to have to report the median, because the median is going to be closer to the true center rather than the average. And similarly, the IQR is going to give you the best if it's skewed. Okay, so the answer is D, median and IQR. Median is resistant to outliers, and so is IQR, and resistant to skewness. All right, so number 2, the box plot below summarizes the heights of 200. There's 200, so I'm just going to put n equals 200 here, just so I remember. Which of the following statements is true? 50% of children in the sample had heights between 93 and 98. Okay, so this is the IQR. Remember, the IQR represents 50% of the data. So that is actually true. We want to look for the statement that is false. Okay, so we would not choose that because it's true. 25 children had heights greater than 98 centimeters. So from here to here is 25%. And from here to here is another 25% to make 100, right? So 25% are greater than 98 centimeters. Well, then what's 25% of 200? 0.25 times 200, that's 50. So that's incorrect, right? So that would have to be the answer. The 25th percentile is a height of 93. This is true. This is the 25th percentile because 25% below it. So that would be true. The tallest child is 111. That would be true. And then every sample in the child was at least 82 centimeters tall. Yep, that or greater than. So that's true. That's definitely B. All right, so number 3, a college professor calculates the standard deviation of all grades from the midterm exam she most recently administered. Which of the following is the best description of the standard deviation? All right, remember the standard deviation is the square. So the standard deviation of all the grades from the midterm exams, standard deviation is the square root of the sum of the x minus mu squared divided by n. And then the sample standard deviation is just the n minus version of that. So sample has n minus 1, and then the population has just n. Now, in any case, it's just an average. You're adding these scores up divided by how many you have. So it's an average, but it's an average distance from the individual values to the average. Okay, so it's the average average distance of the individual data values from the average. Okay, so the difference between the highest score and the lowest, no, that's the range. The difference between the score representing 75 percentile, no. Approximately the mean distance, the average distance, between each individual grade, no, it's not between each individual grade. Approximately the mean distance, that looks good so far, between the individual grades and the mean grade. This is the mean grade, right? Mean grade, and then this is the grade. And then this is just a mean distance. So yes, that's true. And it's not the distance between the midterm exams and the median grade, so that would be incorrect. It's between the mean, right? All right, so it's D. Number 4, consider the STEM plot, which gives the number of people attending a matinee show at the local movie theater for the past 26 days. So we have n equals 26 here. All right, so which of the following statements are true? Let's look at the easy one. Number 3, is the shape skewed left here? Is the shape of the distribution skewed left? Well, it looks like this. So I would say no, that's skewed right if I were to put it on the number line with the bigger number here, right? Bigger here. It would, look like that. So it would be skewed right. So definitely not that. So that would eliminate a lot of choices there. So we just have to see if it's, obviously 2 or 1 and 2. So let's see. Let's look at number, we'll have to see number 1 and 2 because we'd have to eliminate 1 anyways. The 5-number summary is 18, 35, 54, 87, and 81, 23. All right, so the minimum is 18, so that's good. The maximum is 123, so check for that, check that. Let's do the second quartile, which is the median. So they said that there's 26 numbers, which means that the second quartile has to be between the 16th, or not the 16th, half of 26 is 13. So it has to be between the 13th and the 14th number. Okay, so we have to find them between the 13th and the 14th number. So 1, 2, 3, 4, 5. We have to count these. Okay, so 1, 2, and so on and so forth. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and excuse me. See if I can write here. All right, between 13th and 14th. Okay, so it's between those. All right, so between 13th and the 14th, so that means, so it's got to be halfway between 53 and 55, right? So 53 plus 55 divided by 2, which is 54. So that's true. And so half of the data values are larger than 54. That's got to be true then. All right, so doesn't eliminate any choices for A and B because we have to eliminate A. All right, so let's do the first quartile and then third quartile. All right, so first quartile. Now, once we have 26 numbers, and we do the for second quartile, the median, then that means that there's going to be 13 numbers here and 13 numbers there, and so half of 13 is odd. So that means it's going to be the 7th number for the median of the 13, which is the first quartile. So 1, 2, 3, 4, 5, 6, 7. So this is the first quartile, 35. So that's true. And then we got to count it from here because that's where we sliced it in half for the second quartile. So 1, 2, 3, 4, 5, 6, 7. So it's got, so this is 81, and that is incorrect. So it cannot be number 1. It has to be just number 2. So it's B. All right, which of the following statements is true? Histograms have gaps between each bar. No, that's false. Dot plots do not provide enough information to determine if they're outliers. No, that's not true. Bar graphs can display both quantitative and categorical data. No. Bar graphs can only display categorical data, not quantitative data. We use histograms for quantitative. Stem plots are the best graphs for displaying data sets with 2 variables. No. Box plots clearly show the 5-number summary. Yes. All right, so the answer is E. All right, so number 6, distribution has a shape that is strongly skewed left. Which of the following statements is most likely true about this distribution? All right, it says skewed left. That's like the stem, or rather, wrong way. Skewed left here. So if it's skewed left, if this is the median, then the mean has to be in the longer tail. So the mean has to be less than the median. Okay. So the answer is C. Okay. Several students in AP Statistics class administer a survey to a sample of students and their school, asking students how far they travel to school in miles. Which of the following statistics would not be measured in miles? All right, so mean is going to be measured in miles. Median is going to be measured in miles because those are just the middle of the data. Interquartile range is just subtracting the quartiles, so it's still going to be miles. Remember, so the formula for mean is, you add the numbers up, divide by how many you have. Median is just a middle number, so obviously, it's going to be in miles. Interquartile range is just Q3 minus Q1, which is miles minus miles. And then standard deviation is going to be the square root of the sum of the things squared divided by how many you have. But this is going to be squared units, right? But then it divides by, that's going to be squared units on the inside. But then we take the square root of that, so that gives us just miles. So this looks good. And then variance. Now variance, however, is the square root of is the square of the variance, and so that would be in miles squared. Okay, so then it has to be. Then in that case, it has to be miles squared for variance. So it's got to be E. Okay, so the variance is the square of the standard deviation. Okay, so that means it doesn't have the square root, whereas the standard deviation does. All right, so number 8, we said the following table shows high school students in 4 grade levels who ate their lunch on a particular day. Okay, what is the approximate proportion of juniors that purchase lunch off campus? So the probability that they have to be juniors, given that they're juniors, that they purchase lunch off campus. O for off campus. Okay. All right, so then how many juniors were there? Well, we got to add these up, right? So let's add these up. And then we want the ones that are off campus, so it's 45 of them out of, and then we got to add these. So it's going to be, when you add them, you get 165, which is 0.27 ... So that's got to be D right there. All right, so number 9. A club bowling team has 12 members. The first 10 members bowl a game, and their average score is 156. Okay, so we get that. Here we go. We got X bar or mu, whatever you want to call it. Let's just do the mean for those people. You add them up, divide by how many you have. However, they only have 10 members that they did. So, we know that we have 10 that bowled the game and had the average. So the average for the 10 is 156. So I guess we should call that X bar then, huh? All right, so we got 156, and then we want the sum of the scores. So then we just got to times by 10, right? And that will give us the sum of their scores. So the sum of the 10 people is 1,560. Okay, now the next 2 members bowl 173 and 151. So then the total sum is 1560 plus the 173 plus the 151. That gives us our total sum. And then we can get the average from that if need be by dividing this result by 12. But here they don't want the average. They just want, do we have enough information to find the total? And the answer is yes. Just add these up. If you add those up, you would get 1884. So the answer is yes. All right, number 10, the mosaic plot shows the distribution of favorite math class for students and teachers at East Kentwood High. Based on the graph, which of the following statements is true? So we got intro stat, pre-calc, AP calc, AP stats. All right, so there are more teachers than students. Let's eliminate the easy ones, okay? There are more teachers than students who choose their favorite math class as AP calc. Let's do the percentage ones. 100% of students chose intro to stats. Is that true? No. And this is intro stats right here. This is only 85. This is only 15% right here. Let's label all these bars, by the way. So 80 to 85, that's 5% of the students for pre-calc. Interestingly enough, that more students will like pre-calc. And we got 50 to 80, we got 30%. And then from 0 to 50, that's 50%. All right, so there you go. So those are percentages, and we might as well do it for the teachers. So it's 10% of teachers here. And from 10 to about 65, that's about 5%. And then we got from 65 to 95, that's 30%. And then we got 5% here for intro stats. All right, so let's see. So if 100, so definitely not 100%. That can't be right. That choose intro stats. It's only 15%, right, of students. 80% of students choose AP Calc. No, they 30%, right? So not that one. Those are easy ones to get rid of. Now let's do the other one. So there are more teachers than students who choose their favorite math class as AP Calc. Now you got to understand that the area represented by in a mosaic plot, the area of each segment in the bar, in the segmented bar chart, if you will, on mosaic plot, represents a number of people. Okay, so that want that particular subject in this case, right? So we have to see how much bigger is this width or that length or whatever than the other one, right? So this is teachers. So if I do that, this is like 1-ish, 2-ish, 3-ish, 4-ish, maybe like 5, okay? So it's about 5 times bigger. So let's just say that this is equal to 1, and then we'll say that this is equal to 5, okay? 5 times bigger. That's just saying that there's one teacher for every 5 students, basically. That's what it's saying. And that's what we need. We just need that to compare the sizes anyways. So we'll make the number easy. And so we know that this area is 10. This area is 55 because 55 times 1. This area is 30. And then this area right here is 5. And we can use that to help us. And then 50 times 5, this is an area of 250, right? And then this is an area of 150. This is an area of 25, just to make things easier for you. And then 5 times 15, that should be 75, right? So 75. Okay. And this kind of represents the area. So then it says there are more teachers than students. So that means there's a greater area for teachers for AP Calc than students. Well, okay, so we know it's 55 for the area for AP Calc. So is that the same for here? It's 150 for students versus 55. So definitely not. It's definitely more number of students than teachers. So there are more teachers than students? No. When combining students and teachers, AP Stats had the highest overall proportion who chose it as their favorite class. Okay, when combining students and teachers, well, that's 250 plus 10, right? So that's 260 folks. All right, so 260 folks. Now, is that more than anybody else? It says has the highest overall proportion who chose it. So that's 260 when combining students and teachers. So 260 out of how many exactly? We have 250 plus 150 this is 400. So then 425. That's 500. Okay, so it's 500 here. And there's 100 here, right? So it's out of 600. Okay, so in that case, 260 out of 600. If we just compare. So that's 43%. That's pretty high. 42%. So 40 looks pretty high. If I do 150 plus 55, that's definitely less than 260. 25 plus 30, that's 55. That's less than that. 75 plus 5, that's definitely less than that. So this is the biggest. So AP Stats, if I combine these two areas, it's bigger than anything else. We can see that visually. So this has got to be the answer, C. And there are definitely not more teachers than students if you look at this, right? So definitely not. All right, so that's going to do it for the video, guys. Hope you found this useful and informative. And as usual, I'll see you in the next one.